All right, hi everyone. I'm Cindy Norton. I work for the Arizona Remote Sensing Center at the University of Arizona. I got hired on last year as a research technologist. So my main project is in classifying woody vegetation in a semi-arid region. Oh yeah, can you go next? Yes. I started on as a, in this project, it's a rabbit project, rangeland brush estimation toolbox. It's going to be available for the public. They're trying to publish this year. So they map woody vegetation, and my role is to optimize and make their processes faster, and an addition layer, a species-specific addition layer. So they do percent woody cover for all Western U.S., the MLRA areas. And so my role is to add a layer of species-specific where data is available. So I start off, right, with neon. So neon has all of these areas throughout the Western U.S. Where they have long-term studies. So I started with I used their hyperspectral and their LiDAR data. And I started, my first plot is at the my first plot is in the Santa Rita experimental range. They have their hyperspectral is 400 bands, and they have LiDAR for the entire area. It's like 21,000 hectares. And so, first, I basically took all of their available hyperspectral from multiple years. So they have 3 years of data. And so I took all of that data and I ran it into R and created indices for all 3 years. So to avoid using all of the hyperspectral bands, I converted the hyperspectral data to indices. So super quicker processing. So once all of these years, 3 years of data, 14 years of indices, that's 130 images each year. And so it's combined for that whole Santa Rita's. After I got the hyperspectral, I got the LiDAR data. So same 130 LiDAR images, and I converted them all into canopy height models to get the structure of vegetation, the height. And so that I combined those data. So I take all of those years and I combine those data onto an overlay, and I collect training data with what that is. So, so this is a indices composite. So I use it to visualize what vegetation is on the ground, and we also flew drone. So we have high resolution drone images to help collect for the training. So I collected training throughout the Santa Ritas. These are we have drone images collected from last year from colleagues, and I collected additional ones through areas that I wanted more training data. So yeah, I just collected images. I collected training data. These are the different areas. Yeah, you can go next. So yeah, this is what it looks like. Like I trained from the computer, so I just look at it. Like I know this is what cactus looks like. So from the bright, these are the indices composites. So it's a NDVI for green or for red. Green is the 𝐀𝐫𝐢𝐳𝐧𝐚 index, and blue is a 𝐴VI index. So that helps visualize what vegetation is on the ground a little easier. So there's a high resolution on the right, and on the left is a neon 1 meter. And so I just put polygons on these trees. Yeah. So yeah, these are just what they look like and their reflectances. So just from the indices themselves, you can clearly see that it can delineate the different species, right? Cactus, mesquite. So yeah, they just collected training data. Go ahead. Yep. Just keep going. Yeah, so with all of that data combined, I ran my classification to 3 different classifiers: the CART classifier, random forest, and the support vector machine. And I also used different data sets. So I ran only 1 year, and I ran multiple years, and then I ran all the years together. And so I also ran only the indices, and then indices with LiDAR and sort of comparing which one had the better results. And so the results were that it was better to have the indices and the LiDAR for all years than just using 1 year of data set produced with that accuracy. So yeah, the next slide will show the overall. So this is Santa Rita's. And yeah, so the goal is I will be creating a species classification for all the neon data available that falls within the MLRAs. And this will be readily available for people as well once it's done. Yeah, that's pretty much it. Oh yeah. So this is basically shows. Sorry, yeah, this shows how the classifier is able to pick apart the different species, right? So it shows that there's differences in height and differences in these spectral indices and how to classify it. So yeah, that's it. It builds off of the 𝐀𝐫𝐢𝐳𝐬 index that was Jeff shown.
Anyone have questions?
Something I'm observing, this is going to be a general question for all you guys that are doing the veg analysis. Like I come from the capital improvement and civil engineering side of it. We're always trying to get bare earth. Having difficulty classifying out vegetation sometimes. And something I personally have never done on a project that I've run is try to get this multi-spec data.
Hyperspec?
Or hyperspec.
Yeah.
So I don't know, the light bulbs are going up in my mind of like, if this is like a publicly available, like.
Yeah, so Neon has a publicly, readily available. It's like 400 bands. And hyperspectral just works better in delineating bispectral, right? They're limited by those 7 bands. And without the LiDAR too, there's that limitation. Without LiDAR, you still can sort of delineate certain species. Both of them kind of really pop out. And I find this in different areas as well, like where there's more like pine and that kind of area.
Have you heard of anyone specifically doing that, where they're just trying to get better bare earth models? They're using it to better classify vegetation.
Right. No, not just bare.
There's tons of algorithms, point clouds, and that. Something.
Right. The KM.
So there's no reason to try to use hyperspec to identify what is.
Okay, because I've noticed like desert sage, because it's kind of a rock looking plants, from just all you have is a point cloud. Like that one we can't get rid of. It seems like it'll do really good on something that you get like that multi-point return. I think is one of the algorithms that they have. So like a Palo Verde or a creosote or that kind of thing, when you pitch those up and look at them from the side, you've got returns all over the place, and they can sample out that ground. But then you get something that's got a really packed canopy on it. It's like desert sage is the one that comes to mind most, because it just looks like a rock. And then, in those areas, it's like all my verticals are born by 2 feet. And I'm in there trying to get, a couple of tenths of, so it's like it matters a lot. So, but desert sage even will have blind spots. And I haven't found an algorithm yet where I can be like, that's the ground, that's the bush. And I'm wondering if this the hyperspec type of thing.
Yeah.
Good, it's just hyperspec is not available in places.
Right.
Like neon stuff is in like Santa Rita experimental range, and then
I'm thinking about starting to specifically ask for it. Just see what contractors have available. I know these things keep miniaturizing. That's one of my big takeaways. Well,
Are there other questions, comments? Can't see them. Thank you, Cindy.